Welcome to the third video of the example problem for unsymmetric bending. In this video, we'll go through identifying the points that have the maximum and minimum stress, and we'll identify the stress at 3 points, one of which we will know for certain when we do it that it is the point of maximum compression, and two of which we're not sure exactly whether they are the points of maximum tension until we actually identify what the tension is at those points. So, should be fun. Now we've determined that on our cross-section, our moment is applied along this axis. We now want to determine the points of maximum stress. So when we're looking at this, we can pretty easily tell that the maximum tension from the moment about the z-axis is going to occur somewhere along the top, right? Because we're rotating about the z-axis, which is in this direction. And we can also tell that the maximum moment from our moment about the y-axis is going to occur somewhere along this far left-hand side, not right. So when we're looking at those, there's one point that is along both of those lines. It's right there in the top right. So we know right off the bat that our tension is going to be maximized at this point right here. So let's go ahead and find what that will be. The equation that we want to use is that the normal stress in the x direction is going to be equal to negative the moment in the z direction times our lever arm in the y direction divided by our moment of inertia in the z-axis plus the moment about the y-axis times our lever arm in the z direction divided by our second moment of inertia about the y-axis. Now, you can pay attention to this negative sign and the negative signs of these. I would caution you to really think hard about every action that you're taking. In this equation, it's really easy to forget negative signs. My personal preference is to not think about them in just the abstract case of a negative value, but to think about them as this is causing tension or this is causing compression. It very much improves things. I think it really prevents you from making mistakes. So in this case, we're going to have a negative, or we're going to have a positive value for our y. It's going to be positive. That's 2 inches. Our centroid is at 1.25, so that's going to be positive 0.75. This z lever arm is going to be negative 1.25. So this will end up being our positive 15 kip inches made negative times that lever arm that I just said was positive 0.75 inches divided by 1.0833 inches to the fourth plus 10 kip inches. That's our moment about the y-axis times our lever arm. The z direction is going to be negative 1.25 inches. Good, because both of them should be causing compression. We said red was the lines of Mach compression from those two things, divided by our moment of inertia of the y-axis is 3.0833 inches to the fourth. This is going to be equal to negative 14.44 KSI. And it's pretty self-evidently going to be the maximum compression experienced. However, the maximum tension is a little bit trickier because, oh, let's not use red again, huh? The maximum tension due to the moment about the z-axis is going to be down here on this bottom. And the maximum tension due to the moment about the y-axis is going to be over here. So what we're going to find is there isn't a point, like there is up here, where those intersect. And because there is no point where they intersect, well, we've got two potential candidates for maximum tensile, or maximum compression, or no, yeah, tension. Maximum tension. So it's either going to be right here, or it's going to be right here. And we don't know which is which. So let's do number one. Now number one is going to have a very good number for our Z lever arm, right? That Z lever arm is going to be 1.75, pretty big. But our X lever arm is not going to be so big. It's only going to be 0.25. So that's going to be a little smaller. So the normal stress at point 1 is going to be, same equation as before, negative our positive 15 kip inches. But this time, that's our moment about the z-axis. This is only going to have negative 0.25 inches. Right? Be careful with that because we're going down 0.25 from the centroid. Plus our 10 kip inches times a very large 1.75 inches. That's positive because we're moving from here to here. Oh, let's divide these by our second moments of inertia. .0833 inches to the fourth, and that is going to give us 9.13 KSI. Now, we're also going to need to look at point 2. This one has a greater distance in the y direction, so our moment about the z-axis is going to get a little bit more, but it has very little in the way of a moment of lever arm in the y direction, or sorry, in the z direction, for our moment about the z-axis. So let's look at that. We're going to have negative our positive 15 kip inches. This time we do get a lever arm that's pretty good. It's negative 1.25 inches, the most we're going to have. Divide that by our second moment of inertia, oh goodness, there should be a 0 there. 1.0833 inches to the 4th plus 10 kip inches times, this time our lever arm will be negative 0.25 inches. So we're going to end up, and divide that by 3.0833 inches to the 4th. You can see we could have 0.125, or we could go all the way up to 1.25 there. Obviously the minimum there is going to be the best. And what we're going to end up with this one is 16.50 KSI. So it was readily apparent immediately that our maximum tension stress would occur right here, because we're summing a thing that has a simple triangular distribution of stress maxing up here, and another one that is a simple triangular distribution of stress that maxes out here. Where they meet is obviously going to be the maximum. It got more complicated when we came down here, and we weren't sure where the maximum tensile stress would be, but we determined that it would be right there, which does make sense, right? This is the direction of the moment, but the direction of the neutral axis was actually less than that. It was what was it, like 13 degrees? So barely not about the z axis. So there's our maximum tensile stress right there. Is going to occur at this point. Okay, this is a tricky topic that involves 3D thinking, and that's always difficult. So take it slow, and have a good and safe week.